Hello, welcome to my channel. We have been solving this past question papers. So right now we have this mathematics paper 4 for mechanics, and it's May June 2024. We already solved two questions in this paper. You can check my previous videos. Question 1 and 2 we solved. So let's begin with question number 3. Okay, I think it's pretty straightforward question. A train of mass this much ascends a straight hill of length this much inclined at an angle 1.5. So basically, there's a horizontal surface, and for a horizontal surface, there's an inclined plane who's 1.5 kilometer long. Okay, and its angle is 1.5 degree. Okay, and a train is ascending uh, this slope, right? Okay. So in the beginning, its speed was 45 meter per second. At the top, it reduces to 40 meter per second. And the resistance to motion was 12,000 kilojoules. Okay, so we need to find out the work done by the engine of the train as it ascends. Okay, so when train goes from this point to this point, it gains some potential energy, right? Okay, so let's see. The change in potential energy is equal to mgh. Okay, and we know the mass is 1800, 180,000, 180, 180,000 kilograms. Okay, 180,000. Okay, G we have been using is 10 meter per second square, and H would be this H, right? How much height it has acquired. Okay, and this height would be which is 1.5 kilometer times sine of 1.5 degree, right? So in meters, it is going to be 1,500 meters and sine of 1.5 degree. So when we did all this math, we gave this number 7677 and then 760, and this is in joules. Okay, mass is in kilogram, this is meter per second, and this is in meters, so this is in joules. Okay, so we have gained this much potential energy. Now how about change in the kinetic energy? You see, kinetic energy is reduced. The initial speed was 45, then now it is 40, so it is reduced. So this answer must be negative. So final energy is half mv square. Uh, okay, so vf square minus initial energy is half mvi square. So this would be half, and m is 180,000. And then VF is 40 square minus 45 square, right? So this all comes out to be minus 38,250,000 joules. All right, okay. Now the work done, we are going to find the work done by the engine, right? Work done by the engine. Okay, so it is how much energy we have gained. It is this much, 760,006 joules minus this amount, which is 38,250,000, and plus this much energy, because 12,000 kilojoules has been by the motion to the friction. So that work or that energy has also been provided by the car engine. So we have to add into this this amount, which is 12,000 thousand and kilojoules. I put three more zeros here. Okay, so this all comes out to be 44,427 and 760 joules. And if I are to give it answer in kilojoules, so it is going to be 44,428 kilojoules. Okay, I hope you understand this question. The logic was very simple for this question. Okay, let's move on to question number 4 now. Okay, so a car of this much, so there's a horizontal surface. On the horizontal surface, there is a car and it is connected with a trailer, right? The mass of the car is 1700 kilogram and the mass of the trailer is 300 kilogram. The speed of this combination is 20 meter per second. Okay. The resistive force on the car was 400 Newton and the resistive force on the trailer is 150 Newton. Okay. And this connecting cable, it has a tension of T in it. Okay. What else? And yes, the car engine is exerting, the power of the car engine is 14,000 watt. Find the acceleration and the tension in the this cable. Okay, remember work is equal to force into distance. If I divide by time, then work divided by time become power, and it is force and distance divided by time will become velocity. So force into speed or force into velocity give you the power. So from here you can see that the power is, or the force is equal to power divided by the speed, right? Okay, so let's calculate the force of the provided by the car engine. Okay, car engine is exerting a power of 14,000 watt and the speed of this whole combination is 20 meter per second, right? 20 meter per second. So this gives you 700 Newton. Okay, this is the force given by the car engine. Okay, now next thing is that uh, we know that acceleration is equal to force divided by mass, right? If you consider the whole thing, the force given by the engine is say 700 and mass of the whole arrangement, it is 1700 plus 300, so it's 2000, right? And this will give me 7, sorry, oh, sorry. It's not 700, it is 700 minus this resistive force of 400 and 150. Okay, so the resistive force is 400 and 150. So from the applied, the force provided by the car engine minus these resistances, that is the net force which is causing the acceleration. Okay, so let me remove this thing and I have to calculate this quantity, right? And this comes out to be 0.075 meter per second square. Okay, so I have this first easy. Now we have to calculate the tension in the cable as well. So we need to analyze things in a different way. So this is the car, for example, right? On the car, there is a resistive force of 400 Newton. We know that, right? And there is a resistive force by the tension. We don't know how much it is, but this tension is a resistance, a force that is trying to stop the car, right? And the car engine is providing a force of 700 Newton, right? Okay, so if I write and the acceleration, net acceleration is A, and we know the mass of the car is 1700. So if I apply the net force and the Newton's second law of motion, so the net force is 700 minus 400 minus the tension. Okay, this is the net force, and this force is equal to mass into acceleration, and mass is 1700 into A. Okay, I hope you are okay with this equation, right? So 700 minus 400 is 300, minus T is equal to 1700 into A. Now consider the trailer, right? On the trailer, there's a force pulling it, which is T. The resistive force is 150 Newton, right? Acceleration is A, the same acceleration as the acceleration of the car. So if I apply the second law of motion here, the net force is T minus 150 equals MA, and mass of this trailer is 300 into A. Okay, I hope you're okay with these two equations. Now things are easy. If I just add these two equations, so minus T plus T will cancel. 300 minus 150 is 150 equals 1700 plus 300 is 2000 into A, and it will give me A equal to 150 over 2000. It's the same thing which we had this before, and it will give me the same acceleration value 0.075 meter per second square. Okay, so we already have this thing, but anyway, it's confirmed. Now let me put the same value of acceleration in any of these equations. Let me put in the second equation. So we have T minus 150 equals 300 into acceleration, which is 0.075. So T would be equal to 150 plus 300 into 0.075, and this will give us the value of 172.5 Newton. So this is the tension in the cable joining the two objects. Okay, I hope you understand both question and the philosophy and logic behind these questions. This is important to understand so that you can apply these concepts in any question you will come across. Thank you for watching. If these videos are helpful to you, then please subscribe my channel. Thank you very much for watching. See you in the next video.